In this video, we're going to take a look at adding nodes or inserting nodes into our linked list, and I have just shown two different kinds of situations here. One where the start pointer is null, which means we do not have any nodes in the linked list, and all of the nodes as of now are lying in the free list. Remember, this is our free list, right? And the other situation is where we have a few nodes inside of our linked list. So this is situation number 1, and this would be situation number 2. And now we are going to write a code to insert a node into the linked list. But just remember this: some part of the code I'm not going to explain in detail. I have already, for example, explained how to steal a node from a free list in my video on queues, right? When I posted a video on adding a node to a queue, right? You need to go through that video to understand the piece of code that is related to stealing a node from a free list. Because essentially what we are going to do is, first we are going to take a look at the free list and we'll see if we have a few nodes available. If we have some nodes available in the free list, only then we are going to add those nodes to our linked list. Okay, so what I've done here is that I've declared a procedure called insert node, and in this procedure I'm passing a data value. So this data value that I'm passing as a parameter is the value that is going to be added to our new node, and finally that new node is going to be added to our linked list. So the first thing that we want to do is we want to check if we have some free nodes available in the free list. That is what we are doing here. If free list pointer is not equal to null, that means we have some free nodes available, and now we can steal a node from the free list and add it to first we are going to steal a node from the free list, and then we are going to add it to a linked list. So let's take a look at the code related to stealing of a node from the free list. Okay, so this piece of code here is the code that is related to stealing of a node from a free list, and I've already explained this in great detail in that video on queues, right? So you can take a look at that video to understand how this code works. But essentially what we've done is we've stolen the node from the free list. Now that we have the node available to us, and remember this new node pointer, this is basically pointing towards the free node, right? So we've just declared this new node pointer. We're going to use it temporarily, but this is a very important pointer, and we have this is pointing to our new node, right? Now that we have a node, right? Now that we have a node like this, and the new node pointer is pointing towards this node, right? And we've stolen it from the free list. We can now we can now go through our linked list to find the point where this new node is going to be connected. Okay, and remember, the new node pointer is pointing towards this new node. So whenever we are going to connect this new node to our linked list, we are going to take the help of new node pointer. Now before we do anything further, I need to explain one very important concept to you. Whenever we have to add a node, whether it is the linked list or the binary tree, whenever we have to add a node to the linked list or we have to add a node to the binary tree, we are going to need two temporary pointers instead of one. So we are going to need two temporary pointers. So we'll have to declare two more pointers for us to help us in adding a node to the linked list. So whether it is the linked list or the binary tree, we're going to need two temporary pointers. And let me explain why we are going to need these two temporary pointers. Let us consider this situation where we have a linked list. It is an ordered linked list. The first node has a data value of b, the second node has a data value of D, and the third node has a data value of L. Now let's assume that the next value that is going to be added to the linked list is the value C, and obviously we stole a node, right, and we added that value C to that node, and the new node pointer is pointing towards the towards this node, right? So we stole this node from the free list, and now we want to add this node to our linked list. Okay, and we can see that the linked list is ordered, right? Now the way to do this is, we are obviously we first want to set TNP to point to this node, right, to the starting node, and we are going to, so this becomes our current node, right? So this node becomes our current node, and we are going to check, we're going to compare C with B to decide where we are going to position this new node, right? Because C is greater than B, that means we have to move TNP forward, right? We have to move TNP forward, we have to update TNP. So before we update TNP, just remember this, and this is a very, very important step. Before we update TNP, we take another pointer, let's call that pointer PNP, and this second pointer kind of acts like it is following TNP, but it's one step behind TNP. So basically what we wanted to do was, we wanted to move TNP to go to the next node, but before TNP takes the jump, before TNP is updated, PNP is made to point to the same node that TNP is pointing, and then TNP takes the jump, then TNP is updated, right? So this step is very important. Every time TNP wants to take a jump, right before that PNP is set equal to TNP. That way PNP is always one step behind TNP. So in this case, suppose we set PNP to point to the same node as TNP, then we updated TNP, so TNP will now move to this node, whereas PNP is still on the node behind TNP, right? So PNP is still on the node behind, whereas TNP has moved forward. Okay, so now this becomes our current node, right? This becomes our current node. We compare our current node, we compare the data value of our current node, which is D, with this value C, right? And we can see that C is less than D. Previously C was greater than B, so we moved forward, but this time C is less than D. C is less than the value in our current node, so we are going to stop. When we reach this situation, when the value that we want to insert is less than our current node, and remember we are talking about ascending order, first comes B, then comes D, then comes L. Obviously C is going to be inserted somewhere here between B and D. This is when we are discussing ascending order. If it was descending order, you will have to use common sense and apply your logic as to when we have to stop, right? So if it was something like L, D and B, if this was how our list was ordered, then obviously this would be our stopping point, right? So we'll start from here, we'll come to this node, we'll move forward, we'll come to this node, we'll move forward, and then we'll stop here, because this point in between is the point where we want to add C. But that would have been the case for a linked list in descending order. Here we have a linked list in ascending order. So in this case, when the value C becomes less than the value in our current node, we have to stop. Okay, so that's the rule. Before, every time TNP is going to take a jump, before TNP gets updated, right before that we set PNP equals to TNP. And when are we going to update TNP? We are only going to update TNP if the value of C is greater than the value lying in the current node. So if the value of C is greater than B, we are going to take that jump, we are going to update TNP. Okay, but if the value of C becomes less than the value in the current node, we are going to stop. Okay, let's imagine another situation when the new value that has to be added is P, right? So what are we going to do? We're going to set TNP here, right? And this becomes our current node. We compare P with B. P is greater than B, so we have to move TNP to the next node. But before we move TNP to the next node, we set PNP to point here, and then we update TNP, and TNP now moves to the next node. And now this becomes our current node. We compare P with D. Because P is greater than D, we have to move TNP, right? But before we move TNP, we are going to make PNP equal to TNP and then move TNP. So TNP now moves to this node, and PNP was here, right? Okay, once we've reached this node, this becomes our current node, right? And we compare P with L, and once again P is greater than L, so we're going to have to move TNP. We're going to have to move it further, right? So this time we set PNP to become equal to TNP, and then we update TNP, and we can see that this pointer is null, so TNP is going to become null. So TNP is going to become null. And so we've understood our two situations. One of the situations was that, you know, we have to keep moving TNP till we find the point of contact, and that could be anywhere, you know, between the nodes, right? Like C is getting inserted between these two nodes. So once we find that point, we have to stop moving TNP. And the other situation that we've just discussed is that we keep moving TNP, right? Sometimes it happens that TNP becomes equal to null, and that is the point where we have to stop, right? So these are the two situations where we have to stop. One of the situations is when TNP becomes equals to null. So as long as TNP is not equal to null, we can keep moving TNP forward. And the other situation is when the value of TNP, like C, right, when the value of the current node D becomes greater than the value that is to be added, so D is greater than C, that is where we stop. So as long as the value of the current node is less than the value that is going to be added, because B is less than C, we are going to update TNP, and we are only going to stop when the current node has a value that is greater than the value that is going to be added. I just go through this again, right? Go through my wordings again so you better understand. We are only going to move forward when the value C that is going to be added is greater than the value in the current node. That is when we have to move TNP forward. So let's add what we've just discussed to our code now. So what we've done is we've declared the temporary pointer TNP, and we've also declared the other pointer PNP, and then we've set TNP equals to the start pointer. So we've positioned TNP to the start of our linked list. So once we've declared TNP now, and we've set its position to the first node of the linked list, we are now ready to move TNP from node to node to find that point where we are going to add the new node, right? So we have to find that point of insertion. Now the way to move TNP forward, we are obviously going to set up a loop, and we can see that this code is fairly logical, right? As long as TNP does not become equal to null, and as long as the data item, the new value that we are adding, right, it is greater than the data value of our current node, right? As long as the value that we are trying to add is greater than the data value of our current node, we are going to run this loop, right? Okay, so as long as TNP does not become null, and as long as the data item is greater than the data value in the current node, this loop will keep running. Okay, so when this loop runs, what we want to do is we want to update TNP and move it to the next node, right? But before we do that, we have set the value of PNP equals to TNP. So before TNP gets updated, we make PNP equal to TNP, and then we update TNP. So this way PNP is always a step behind TNP. Okay, before we start writing code on linking the new node in the linked list, just one final situation that we need to consider. What if we have a value like a, right? So we want to add a to this linked list, and to do that we start off by setting TNP to the first node, right? And in this case we can see that a is less than b. This becomes a current node, right? So when we compare the value in our current node with a is less than b, which means we do not want to update TNP. And I don't know how I've written this p here. So we don't want to update TNP, right? Because a is already less than b, we don't want to move TNP forward. And even if we take a look at this code here, right, we've set TNP equals to the start pointer, and in this situation when we take a look at the condition for the loop to run, one of the conditions is that the data item that we're trying to add, which in our case is a, must be greater than the data value lying in the current node, which in our case in this example is b. And we can see that a is not greater than b, which means we are not going to go inside the loop. We are not going to go inside the loop because the condition is false. This condition is false, which means TNP is not going to be updated, which means PNP is not going to be set equal to TNP. We are not going inside the loop. So this is one situation that you must understand, because in this situation what's going to happen is that this node, this new node, is going to be linked here, right? A is going to be linked somewhere here, right? The start pointer should point towards a, and then they should be pointing here, right? So this link will have to remove, right? And this is how we should be linking up, right? Okay, so in a situation where TNP has not moved, where TNP is equal to start pointer itself, right? TNP is pointing to the same node that we initialized it to, right? We set the initial value of TNP to be equal to start pointer. So in case TNP has not moved forward, the only reason TNP has not moved forward is because a was less than b, which means in such a situation when TNP has not moved forward, this new node pointer is going to be added to the head of the linked list. The start pointer should now point to this new node, right? And this should be the position of the new node, and then this new node should link to b, right? So this is one situation that we need to code in case TNP has not moved, in case TNP is still equal to start pointer. So so this is what we've done. What we've said here is, after this loop, after we've set the value of TNP equals start pointer, after we've set up this loop, the first thing that we're going to check is whether the value of TNP is it still equal to start pointer. If the value of TNP is still equal to start pointer, that means that the new node that we have is the node that is going to be added to the head of the linked list. And remember, this was the situation that we had. So this was our situation, and now we have to do our linking, and we must be very careful. See, if we link this pointer to this node first, and remember TNP was pointing here, right? TNP was pointing here, right? So if we link this part first, then there are two nodes pointing, then there are two pointers pointing to that same node, right? Right now start pointer is also pointing towards this node, and new node pointer is also, and this pointer value of our new node is also pointing towards the same node. And that is what we are doing here, right? We are setting the value of the node in our array list, the node that new node pointer is pointing at, right? This is the node that we stole and that we want to link. We want to set its pointer value equal to start pointer, which means what? This pointer value is going to point to the same place that the start pointer is pointing at. We could have written it like this, or we could have also used TNP instead of start pointer, because in this situation TNP is also pointing to the same node, right? So both of these could have worked. We could have used start pointer here, or we could have used TNP. We can see that they're both pointing towards the same node, right? Okay, once we have linked our new node, after that we are going to change the value of start pointer. Now we can direct the start pointer to point towards this node. So now start pointer should be set equal to new node pointer, and this is a very important sequence. If you get the sequence wrong, if you don't set this pointer value first, we are going to end up making a mistake, and let me show you what I mean by that. Okay, so what I've done, just to illustrate what I mean, what I've done is so this was our original sequence, right? This should happen first and then this should happen second. I've written this same piece of code, I've written this code here, but this time I've changed the sequence. First I am setting the value of start pointer to point towards the new node pointer, and then I am trying to update the pointer of our new node, right? So I've changed the sequence here. I've moved I have moved this instruction to the front, and after that this is the second one that's going to get executed. So let's see if this sequence is followed, what's going to happen. So start pointer has been set to new node pointer, right? If TNP equals start pointer, then the first thing that we are doing is that we are setting start pointer to point towards new node pointer. So in that case, what's going to happen is that the start pointer, instead of pointing here, is now going to point here. So we've linked the start pointer to this node here, and now we want to link this node to this node, right? But what are we saying here? We are saying that in our array list, the node that is lying at the at the place towards which new node pointer is pointing, right? That new node, its pointer value, set it equal to start pointer. But where is start pointer pointing? Start pointer is pointing here, and so now there is a problem, because we want to point towards this place, but there is no pointer pointing towards this node right now. The only pointer that was pointing towards this node was the start pointer, right? And what we did was we moved the start pointer from this to the new node. So once we've moved the start pointer away from this node, then there is no pointer pointing towards this node. So how can we set this pointer value to point towards this node when we don't have any clue of where this node is lying, because no pointer is pointing towards this node right now? I hope you understand what the problem is. So this sequence is very important. Always when you have to add a new node, you must always first configure the pointer in the new node. This is a very important sequence. Whether you're adding a pointer, whether you're adding a node in a binary tree or you are adding a node in a linked list, always first set the new node, its pointer, always set it first, and after that you're going to configure the other pointers. So this pointer must always be set first. Okay, so this situation happens when TNP is equal to start pointer. Okay, but what if TNP was what if the start pointer was null? What if we did not have any node? What if we did not have any node in our linked list? What if the start pointer was null? If the start pointer was null, then TNP would have been set to null, right? And this loop would not have run, because this loop is only going to run while TNP is equal to null. So that means what? That means TNP is still equal to null, right? We don't go inside this loop because TNP is null, so this loop does not run. And when we come to this loop, when we come to this line, we see that TNP is null and start pointer is also null, right? Because that's the situation that we're considering. So if TNP is still equals start pointer, what are we going to do? We are going to first configure the pointer of our new node. So the new node A, its pointer is first going to be set equal to start pointer, and start pointer in this example is null, so this is going to be set null, right? And then we are going to make the start pointer point towards the new node pointer, and so then afterwards we are going to make this link up. So this code works fine, right? This code works fine. So let's consider a situation, let's consider the other situation. The other situation that we had was that we had a value like C, for example, and C was going to be inserted between these two nodes, right? So this time we don't have a value that's going to be inserted at the head of the node, but somewhere in between the other nodes at the midpoint. What's going to happen if TNP has moved? If TNP has moved, if TNP has been updated, what is that piece of code that we are going to use to link the new node between the other nodes in our linked list? So in the else part, and the else part is where TNP has moved, right? Initially TNP had not moved, it was still the same as the start pointer, but in this case, when TNP has moved, what are we doing? Once again, we are first going to update our new nodes pointer. Okay. And let me just draw the diagram so that we can understand how these statements are working. So let's say this time the value that we were going to add was C, right? This is a situation that we've already discovered, right? We've already discussed, right? So first we set the value of TNP to be here, and then we compared C with B. Because C was greater than B, we wanted to move forward, right? And before we moved forward, we set PNP here, and then we move TNP to the next node. So now this node becomes our current node. When we compare this value D in the current node with the value C, we realize that C is less than D, therefore we are going to stop. So this loop stops, right? This loop stops. At the point that this loop stops, the TNP is here and PNP is here. Now so we come to the else part, right? This was the part where TNP had not moved at all, but the else part is where TNP has moved, right? So once TNP has moved, these are the two statements that are going to get executed, and let's take a look at these statements. So what we are doing here is, first, as I told you, always set the pointer value of the new node, and that is exactly what we are doing here. In our array list, the node that new node pointer is pointing at, which is our new node, its pointer value should be set to this node. Now there are many ways of doing this. We could have simply set this pointer value to that of TNP, right? Instead of writing this, we could have set it to TNP, right? That's one way of writing the code. So you can use your common sense. But the other way of writing the code could be this also. The other way of writing the code is that you can make this pointer point to the same node that the previous node towards which PNP is pointing, its pointer is pointing. See, TNP is pointing towards this node, and this pointer is also pointing towards this node. So what we are saying is that in our array list, the node towards which PNP is pointing, its pointer value should be given to the new node pointer. Its pointer value should be given to the pointer value of new node pointer, right? So both of these work the same way, whether we set it equal to TNP or whether we set it equal to this pointer right here. Okay, once we've set up this pointer value in the new node, right, now we can set this value, now we can make this pointer point here. And remember, what we want to do is this pointer, this node towards which PNP is pointing, we want to set its pointer value to point towards our new node. Okay, and remember, the new node pointer is pointing towards our new node. So in our array list, the node towards which PNP is pointing, its pointer value should be set to the same should be set to point to the same node that the new node pointer is pointing at. So the value of new node pointer is basically assigned here. So the sequence is very important, and this completes the code of adding a node to a linked list. So one of the questions that the examiner can give you is that you should write a recursive procedure to find the point of insertion in the linked list. So up till now what we were doing was we were iteratively trying to find the point of insertion. So in this while loop we were going through different iterations of the loop. The loop kept running until we found our point of insertion, right, the value of PNP, the final value of PNP and TNP, right. But now he is saying that write a recursive procedure that should find you the point of insertion in the linked list. So let's write code for that. So what I've done here is I've declared my procedure. I've called it find insertion point, right, and I'm passing it 3 parameters. I am passing it TNP, right, which is going to point to our current node, and PNP is always going to be one node behind. And I'm also passing the data item that is basically going to be added to our linked list, right. So the new value that is going to be added to our linked list. So we want to find the point of insertion. And remember that the whole point of writing this procedure is that we want to update the value of TNP and PNP, right. We want to keep moving TNP until we find that insertion point. So that's what this procedure is all about. We are going to have to update TNP, right, by placing recursive calls, right, and before TNP is updated we are also going to update PNP. So that's the whole point of writing this recursive procedure. Now the first thing inside our code that we should check is whether TNP has become null. If TNP equals null, that means we can't move forward, right. So that's one of the first things that we are going to check, whether TNP is equal to null. And you should remember this, when we did this part of the code, then we set the value of TNP equals to start pointer. So what if there are no nodes in the in the linked list? Then start pointer would have been null, right. Then start pointer would have been null, and when start pointer was null, meaning there were no nodes in the linked list, then TNP would also have been set to null, right. And if TNP is null, then we can't, that means we can't move any further. We cannot play, we cannot call we don't want to place any recursive calls anymore, right. So that's one of the first things that we should check once we go inside this procedure. So if TNP is not equal to null, only then we are going to place a recursive call. So that's the first thing that we've done here, right. If TNP is not equal to null, only then we are going to place a recursive call. So after we've checked that TNP is not equal to null, do we really need to update TNP, right? Because what if we have these values B, D and L inside of the linked list, right? What if we have these values, and this is a start pointer, remember, right? And what if the value that we have, for example, if we have A here, right, that we want to add, and remember TNP was initially placed here, right? I should put A here inside, right? Then TNP really doesn't need to move forward, right? So what we want to say is that if the value that we're trying to add is less than the value of our current node, even then we don't want to place a recursive call. If the value that we're trying to add, which for example is A, is less than the data value of our current node, if A is less than B, even then we don't want to update TNP, right? So even in this case we don't want to make a recursive call. So therefore we are only going to make a recursive call. We're only going to make a recursive call if the value in our current node, or if the value that we're trying to add, is greater than the data value of our current node, only then do we need to place a recursive call. For example, if this was Z, right? If this new node had a value of Z, so Z was greater than B, which meant we were going to update TNP, we were going to move it forward. So only if the value that we're trying to add is greater than the value, then the data value in our current node, only in that case are we going to place a recursive call. And now remember, what do we have to do? If we have to move TNP, before we move TNP we have to first update PNP. So we are going to update PNP, then we are going to update TNP, and then we are going to place a recursive call with the updated value of TNP, with the updated value of PNP, and the data item that we are trying to add, right? So the next time we place a recursive call to our function, we are going to add the updated value of TNP. We are going to pass the updated value of TNP as a parameter, the updated value of PNP as a parameter, and the data item that we are that we wish to add, right? And that is exactly what we are doing here. Now we want to place a recursive call, but before we place that recursive call, we have first updated the value of PNP. We've set it equal to TNP, then we've moved TNP to the next node, right? And once we have updated PNP and we have updated TNP, we are now calling the same procedure, right? We are calling find insertion point, and we are passing it the updated values of TNP, the updated values of PNP, and the data item that we are searching for. So what's going to happen now is when this procedure is called again, this new value of TNP will tell us the current node, right? So TNP will now be pointing to another node which is going to become our current node, and then we'll check whether this new value of TNP is not equal to null. If this is not equal to null, and if the current node, the new current node, its data value is less than the data value that we're trying to add. So the data value that we're trying to add is greater than the data value of the current node. If that's the case, once again we are going to update PNP, once again we are going to update TNP, and once again we will have to place a recursive call, this time once again with the updated value of TNP, PNP, and the data item that we are searching for. So we keep placing recursive calls until either TNP becomes equals to null, or we reach a point where the value that we're trying to add, data item, becomes less than the data value lying in our current node. Okay. So now that we've written our recursive procedure, instead of using this iterative solution, this while loop, right, instead of using this while loop to find our point of insertion, we can use our recursive procedure to find the point of insertion. And that is what we've done here. Once we've initialized TNP, we've set its value equal to start pointer. That's when we are calling we are placing a call to this recursive procedure, right? And this is how we're trying to find our point of insertion using recursion, right? And one thing that I forgot to add, I should use the keyword call here. Every time I place a call to a procedure, I should use call here. Let me rewrite that again. Okay, so this looks fine now. We are now using recursion to find our point of insertion using this procedure, find insertion point, right? Once we call this procedure, we come here and we can see that this procedure is placing a call to itself many times until we reach the final value of TNP and PNP, which we'll have available here. Just a concept from P2, this value of TNP and PNP will have to be passed by reference, okay? Because TNP, we want to get the updated value of TNP back, and we want to get the updated value of PNP back. And one other concept which is also related to P2, I have passed 3 parameters here, right? TNP, PNP and data item, and I have not passed this list as a parameter because I'm assuming that this list is a global variable, right? I'm assuming that this array list is a global variable, just like we are using this array list here without having to declare it. So this is a global variable. So even if you don't understand this concept of global variables and why I am passing these values by reference, that doesn't matter. I hope you've understood the rest of the code and how it works.